Okay, so these are going to be your notes on multiplying monomials. So I'll take you through a few examples, and then after that you'll have some questions to answer on your own. So before we do that, monomials have to do with exponents. So when we talk about exponents, we talked about these early in the year. Exponents are going to be repeated multiplication. So when you have an exponent, it means that you're just multiplying the base the number of times that the exponent is. So in order to do that, we want to talk about some vocabulary. So the first thing that you're going to need to know is the number on the bottom. So that's going to be our base. So the base is the number that's getting multiplied repeatedly. The y is going to be called our actual exponent. So that's the number of times that you're going to multiply the base by itself. Another vocabulary word that we've talked about, but I just wanted you to recognize, is sometimes you're going to have a number in front of the base. We call this the coefficient. So coefficients are going to be important for when we start to multiply them. So it is important to know the difference between a coefficient and a base. So the coefficient is the number out front. The base is going to be what's being multiplied and has the exponent on it. All right. So it's just some examples of what exponents would be using regular numbers. So if we're writing the exponents as product of repeated multiplication, 4 to the third, 4 is our base and 3 is the exponent. So that would mean multiply 4 by itself 3 times. So that would be 4 times 4 times 4, and you can actually evaluate that in your calculator if you wanted to. When we have x to the fifth, our base here is not an actual number, it's just x, and the fifth is going to be the exponent. So the x is our base, 5 is the exponent. So that's not something you can enter your calculator, so the only thing we could do with something like that is simplify it or write it in a different way. So that will be simplified or rewritten as x times x times x times x. Notice that we're multiplying it by itself 5 times. So that's what the exponent needs to do. Okay, so that's just our review on exponents. Just then, if we're looking at what we're doing today, is we're actually multiplying monomials with the same base. So in order to simplify them, we have to identify what has the same base. So the base is, again, that number on the bottom. So take a second, try and figure out which one of these have the same base. So if we're looking at the base, again, that's the number on the bottom. So 3 and 3, these would be ones that have the same base. If I'm looking at 5 and 3, 5 and 3 are different. So although the 2 and the 2 are the same, we can't combine those because they have a different base. So that's something to realize. If I'm looking at this one, my bases are y and y. So if you have 2 y's as your bases, those are something you can combine. And if we look here, we have x and x to the third. So x were a little bit confusing because it doesn't have an exponent, but something we are going to talk about and what we've talked about in the past is if a base doesn't have an exponent, the exponent is always 1. But regardless, both of those are x, so they do have the same base. So that's going to be an important to remember for our next step. Okay, so the rules for this, if we would like to multiply exponents with the same base, our first rule is going to be to keep the base the same. So whatever the base that both of them had, you're going to keep it. And the second step then is to add the exponent. So again, those exponents are those little numbers above them. If the bases are the same, we keep the base and we add the exponent. So you'll hear me say that throughout the whole notes. It's something if you want to write that down somewhere so you have it while you're working on your assignments. But keep the base and add the exponents if the bases are the same. Okay, so we have 4 examples for this section. So the first example is x to the fifth and x to the third. So my first question to you would be, how do I know that I can combine these? So the answer is going to be I know because they have the same base. Both of them have the base of x. So just like the slide before, if they have the same base, then we keep the base. I'll write it out here just again. Keep base. Add the exponents. So our base here, like we mentioned before, is x. They're both the same, so we keep that. And then we're going to add our exponents. So our exponents are 5 and 3. So this will be written as 5 plus 3. And we know what 5 plus 3 is. So when we multiply these two together, we're going to add our exponents. So our answer is x to the 8th. Notice that although we were multiplying x to the 5th and y to the 3rd, we weren't multiplying Okay, so example 2, when we take a look at it, it's z times z to the 8. So our first question is always, do these have the same base? So the answer to that is yes. Both of them have a base of z. So if they have the same base, we know to keep the base and add the exponents. So we run into a little bit of problem here. So if I keep the base, I'm keeping z. But what are going to be the two exponents that I add? Because there's nothing on that first z. So the answer to that is like we went over before. If there's no exponent on a base, the exponent is always 1. So if there's no exponent, just like when there's no coefficient, we know it's 1. If there's no exponent, we know that it equals 1. All right, so if we're doing that, then this makes this problem a little bit easier. Once I have that 1 written in, this becomes now 1 plus 8. So our answer to this is going to be z to the 9th. And that will be our answer for example 2. Okay. So now, if I go and take a look at my last 2 examples. So again, all of these PowerPoints are posted with the answers already, so you can see them. So if I look now at example 3 is x cubed times x squared. So again, ask yourself, do these have the same base? So the answer is yes. They both have the same base as x. And then what 2 things would I be adding together? Good, the answer is 3 plus 2, which means our final answer here, simplified, is x to the 5th. So again, notice we are multiplying here. We're multiplying these 2 sets of monomials. However, when we're working with the actual numbers that are the exponents, we're adding those together. Okay, and our last example here. So when I look at this problem, it might be easy to write x to the 5th or y to the 5th. So please tell me why that's not correct. Good, so the answer to why that is not correct is we actually cannot combine these. So we can't multiply these. So if I look, I have x cubed and I have y squared. So those don't have the same base. So if there's not the same base, you can't add the exponents. So the simplified answer is just x cubed, y to the 2nd, and we're done. So that's like a trick question because the question is actually the answer. But the idea, if we're reviewing, and this is what you're going to need to do that assignment for the lesson, is that if you have the same base, which again, the base is the bigger number on the bottom, the bigger variable. So same base means to keep base and add the exponents. And that will be it for this first part of the lesson.